In this lesson, we're going to learn one method to factor trinomials called the TEKS method. And so we're going to see how the TEKS method works. The TEKS method works when we have our quadratics in standard form like this, which is ax squared plus bx plus c. And so we're going to make this big X, and it's going to help us see our factors more visually. And so in this top area here, we're going to multiply our a number times our c number, right? So whatever number is attached to the x squared times whatever number doesn't have the x with it. And then in the bottom, we're just going to put our b term, okay? And so now on these two sides here, we're looking for two key numbers, as I call it, okay? And so we're going to have key number 1 and we're going to have key number 2. What these key numbers are, we want our two key numbers to multiply to the top, which we said was a times c, and we want those same key numbers to add to b down here at the bottom. So we want these two numbers to multiply to the top and then add or subtract to the bottom down here. Once we find those two magic numbers that work, we're going to divide these two numbers by whatever our a term is. We're going to simplify these fractions next, and once we get our simplified fractions, that will tell us our two factors, okay? So we're going to look at 4 different examples of 4 different scenarios that you may run into that the TEKS method will work for. The first one is pretty easy here. It's just x squared plus 7x plus 12. So let's make our x, and now let's figure out what a, b, and c are. So my a is always attached to the x squared. I don't have any number out here, so I'm going to say my a is just equal to 1 because multiplying by 1 doesn't change anything. Next, our b is with whatever has the x, so in this case b is equal to 7. And then that leaves c to be 12 since that's my last number and it doesn't have any x's attached to it. So on top, we have a times c. So we have 1 times 12, which of course is just going to give us 12. And now we're going to put our b term on the bottom, which is 7. So now we have to think, what are some numbers that multiply to give us 12? Well, we could say 6 times 2 can get us 12, but there's no way to add or subtract 6 and 2 to get 7. So I'm thinking, what else multiplies to 12? Well, I know that 4 times 3 would multiply to 12. And if we add 4 and 3, we do end up with 7. So these are our two key numbers that we're working with. And so now we're going to divide these by a, which we said was 1. And so how we get our factors from these fractions here is the bottom tells us how many x's we have, and then the top is whatever we're adding or subtracting. So for this first fraction here, we have 1x, and then we have a positive 4. So my first factor is x plus 4. And my second factor, we have 1x, and then a positive 3. And so we end up with x plus 4 times x plus 3. So this is our factored form of this quadratic. If we were to multiply this out using FOIL or the box method or any other method like that, we would indeed end up back up here because this is just the factored form. So these are the same thing, just in different versions. So now let's look at another example. Let's find our a, b, and c. A is attached to the x squared, which in this case is 3. My b is attached to just the x. One thing that we want to keep in mind here is we want our signs with our numbers. So my b here is going to be negative 2 because we're subtracting 2x. And same with my c. My c here is going to be negative 5 because of this negative right here. So now let's set up our x method. And so we're going to multiply a times c. So 3 times negative 5 is going to get us negative 15. So that's going to be on top. That's what we're trying to multiply to. And then my b goes on bottom, which is negative 2. And so now let's think, what are two numbers that multiply to get us to 15 and add and subtract to get us to 2? Well, I can say that 5 times 3 would get us to 15, but I need it to be negative, so I need to make one of these negative. And if I want these to add to negative 2, I can say negative 5 plus 3 would get me to this negative 2. So negative 5 and positive 3 are my two key numbers. So now we're going to divide both of these by a, which in this case is 3. So I'm going to divide both of these by 3. Now let's see if we can simplify any of these fractions. Negative 5 over 3 can't be simplified, but 3 over 3, we can simplify this to 1 over 1. So now I can use my two fractions to get my two factors. Again, remember the bottom of these fractions tell us how many x's we have. So for this first fraction here, I'm going to have 3 x's, and then I've got a negative 5, so my first factor is 3x minus 5. For my second factor, I have 1x, and then just a positive 1, so my second factor is x plus 1. So this would be my factored form of this quadratic. Let's look at another example. This time we have 2x cubed minus 4x squared minus 6x. So one thing that I notice here is that I've got a lot of x's going on, and we're not in our standard form that we talked about where we have ax squared plus bx plus c. We talked about in a previous lesson, the first step to factoring is always to factor out the GCF. So here that's exactly what we need to do. Let's find that GCF, the greatest common factor of this trinomial. I'm going to look at my numbers first. 2 can only be separated into 2 times 1. And so now let's separate this 4 can become 2 times 2. So if I'm seeing a pattern with 2 here, that means 6 can be separated into 2 times 3. Now let's cancel out what we can between all these numbers. I can take a 2 away from each of these terms. So that means 2 is going to be part of my GCF. And now let's do the same thing with our x's. X cubed, I have x times x times x. X squared, I have x times x. And here I just have the 1x. So now let's take away what we can. I can take away 1x from all 3 of these terms. So that means my GCF is 2x. So now once we divide this, let's see what we're left with. For this first term, I have 1 and then these 2 x's. So I'm just left with 1x squared. And then here, I'm just left with negative 2. And then I have 1x, so I get negative 2x. And here I'm just left with this negative 3. So here is my GCF factored out of this trinomial. And now what we can do is we can use the x method for this inside part here, whatever's inside my parentheses, and then I'm just going to tack on my GCF at the end. So for the meantime, let's ignore that GCF, and we're going to set up the box method just as we have been. My a is now 1 because there's no number in front of that x squared. My b is negative 2, and my c is negative 3. So a times c on top, I've got 1 times negative 3 is just going to give me negative 3 up top. And then my b, negative 2, goes on bottom. So now what are some numbers that multiply to negative 3? Well, the only thing would be 3 times 1. And if we want these to subtract, we want the signs to be different. We want to end up at a negative 2. So I need to make this 3 a negative. So that negative 3 times positive 1 gets us negative 3. And 1 minus 3 gets us negative 2. Now let's divide both of these by my first number, by my a, which is 1. And so my factors, I get 1x minus 3, and I get 1x plus 1. And like I said, we're going to take my GCF and just put that at the front. So this would be my factored form to this original quadratic. And now my last example looks a lot different than what we've been working with. We have x squared minus 81. We can still use the x method for this. We know what my a is. My a is my x squared. And c always doesn't have that x with it, so 81 is going to be my c. But we don't know what my b is. My b isn't listed here. And so what number is no number? 0. So we can rewrite we can rewrite this as x squared plus 0 x's minus 81. And so now we can see that my a is 1, my b is 0, and my c is negative 81. And so now let's factor this out. My a times my c is going to get me negative 81, and then my b is just 0. So now I need my two key numbers to add to 0. So that means I'm going to need the same number here. Luckily, 81 is a perfect square. So 9 times 9 gets me 81. And if I make one of these negative, I would multiply to get a negative. And 9 minus 9 gets me that 0. And so now let's divide these by my first number, which is 1. And so we get x plus 9 times x minus 9 as my two factors. So to summarize, we can use the x method anytime we have a quadratic in standard form. That's ax squared plus bx plus c. A times c will go on top. We're looking for two numbers that multiply to a times c and add or subtract to b. Once we find those two key numbers, we divide those by my a term, and then that will tell us our two factors once we get those simplified fractions. Thanks for watching.